Alright, should be live. Yeah, welcome back. Another instant sudden stream. I'm going to be seeing if I can wrap up M2 support in Asahi Linux. So last time, I made everything that was needed for feature parity work, except for keyboard and trackpad, which shifted to a new architecture. And then I reverse engineered all of that, or pretty much almost all of that. So what's left now is actually implementing what I figured out last time, and yeah, and just basically writing Linux drivers. So hopefully the audio is okay. Can I get an audio check? Let's see how many people show up this time around. Looks like 8 so far. And I'm going to do a bit of planning this time. Cool, audio fine, excellent. Okay, let me switch to the coding view. Just checking. Yep, looks good. Get my chats back. Okay. So yes, let's do a little bit of just sketching before we get started. So I guess the channel 2 was more controlling stuff related to the keyboard. The channel 2? You mean like on the SPI? Yeah, the SPI, not the SPI, the like Dockchannel stuff. There was like the second one was the keyboard, right? The first one was some kind of control stuff. So there's different channels, but I think this is the same as the same thing SPI did. I haven't actually I didn't do the SPI stuff. I don't know what the protocol is like, but I assume it's very similar. It might even be identical, which means this is going to be refactoring that into a separate file and then plugging the other stuff in. But I'll get there later because first I want to just bring up the processor and the dock channel stuff. So a bit of pre-planning before I get started. So there's going to be 3 drivers and 3. Basically, actually, what I'm going to do is I'm going to write the device tree binding first, and or at least sketch it out, and then we'll actually start writing the drivers. Because there's actually more of engineering involved here than actually writing code. Because the thing about the this touch controller is that it communicates with the main CPU via a completely different hardware mechanism than anything else we've used so far on the M1. Even though the M1 had this for a debug channel that is used with proprietary Apple debuggers, we never figured out how that works yet. But so we knew about it. I knew about it. I'd seen macOS use it, but I had never implemented a driver for it. So that's what I prototyped last time. So we need to represent that. Then we need to represent the actual HID interface over that. And then we need to represent the coprocessor that actually runs this stuff, which I believe should be represented as a separate device, because in this case, it doesn't actually do any management. It doesn't even have any endpoints to communicate anything. So it's literally just, like, we already have library code for bringing these CPUs up that is normally used by a driver that then adds stuff on top. This one has nothing on top, literally. So here's my thinking is, let's take NVMe as an example. Actually, let's take, no, one of the ones, oh, we don't have any implemented right now that actually use a Dart, because we don't have DCP brought up. SMC doesn't use a Dart, but that's okay. We can use SMC as an example. So basically, first we're going to have a mailbox. This is the same. The interrupts will be different, but that's okay. Then we'll have the MTP, the actual coprocessor. MTP. And so my idea is that so my idea is that because this is going to be a stub driver that doesn't actually do anything, it should be a generic driver that we can use for other cases where this is needed, if it is for other things. This could have been used for NVMe, but we ended up not doing it like that. The NVMe is a little bit less cleanly separated than this one. Because it does have, I think, at least a couple endpoints that could be used for NVMe, but this one definitely doesn't. So these are called ASC4. Let's just say helper ASC4. Let's call it helper. Yeah, we'll bike shed. AC Pro Partikit boot return 0. Yeah, that's pretty much going to be the whole driver, really. Let's say yeah, like something like that, and then we'll have the generic versions, which would be Apple, MTP, and Apple RTK helper ASC4. And so by doing it this way, we can actually just bind the driver to Apple RTK helper ASC4, and everything else is just there in case we ever need to add like extra things, which we probably don't. There is no SRAM. No, actually, there is SRAM on this one. Yes. So we actually need the SRAM thing, which is going to be the same as SSMC. And that's actually just a whitelist for... because this ASC actually combines SRAM-based direct access and... oh, yeah, and I have to write some minicode, too. I'll get to that later, but I'm going to do part of the init in mini. But yeah, this one combines SRAM access and... like stuff that has to be mapped through the IOMMU. So this will have a mailbox, and then this one has nothing. So that's just gonna be the helper. Then we're gonna need a Dart also. So we're gonna have something like this. I don't know if there's power domains involved here. Probably not. Not any that we care about anyway. I need to check see if there actually exist any though. That probably do exist, but they were probably already turned on. So then we have the mostly just that, yeah. And we need to reference the IOMMU, which is made the Dart. So these three nodes, with which three drivers, two of which already exist, are the coprocessor part of it, and it's pretty much standalone. Then we're going to have the actual Dockchannel. NTP Dockchannel. I don't know what device node this should be. FIFO, I guess. Whatever. I'm actually going to make all these XXX so I don't forget to change them, because otherwise I will forget to change them. And the IRQs. Yeah, so we're gonna have a device representing the FIFO that will be 202 Dockchannel and Apple Dockchannel. And then we're going to need I'm pretty sure we do need a FIFO size explicitly specified, because I don't think that was in any ID register, or if it was, we don't know how it's encoded. Though I should compare the UART one, see if it was the same depth. It might give us a hint, but it's a bit dodgy to try to... I know Apple specifies it in the device tree, so we probably should too. And then... so it's up for debate how this should be represented. But my idea is that because a dock channel could, even though we're going to use only one channel, a single dock channel instance could have multiple channels that are actually in use. Because like, there's a set of interrupt registers. The dock channel is shared between multiple CPUs. There's a set of interrupt registers per agent, like CPU or whatever agent in the system is using the dock channel. And then each one of those can get interrupts for all the channels. And then potentially a single agent could hit multiple channels. So even though nothing is ever going to need more than one channel so far, because I'm writing a binding that will hopefully never change in the future, even if the driver only supports one channel for now, which it might, because we're going to need a new driver anyway for anything that has another channel. That's not a big deal if we add that later, but the binding should support multiple channels because we don't want to have to change that. So my thinking is Apple channel is we give it an array of indices, which is a mapping of, because the interrupts are numbered, so the CPU isn't necessarily going to be using channels starting at 0, or it could be just an arbitrary collection of channels. That will be the mapping between hardware channels and the actual channels that the driver is binding to. Alternately, we could do this with just the child nodes. So this is something that I can work out with Rob later. But for now, I guess we can do it like this. Unless I used like regs for the channels, which I could. That might be good, actually. That's a very... but then the problem is if I do it like that... Hold on. Oh, yes, 1 sec. Sorry, just got a message. So yeah, the main thing is that for the registers here, we're going to need a set of interrupt registers and a set of make sure that we're gonna have the config registers, or I guess config registers and data registers. Why do I have tabs in some places and not others? Yeah, I don't know. Yeah, I'll fix that once I put it in the real device tree. Just 1 sec, sorry. So yeah, so we need a global RQ register set, and then we're gonna need one for each dock channel. And yeah, it's kind of up for debate how this should be represented. So yeah, this is very much up for bike shedding later. But that's okay. We can just go with this for now. So, this will represent the Dockchannel hardware, which will point at a arbitrary subchannel within that, a specific agent interrupt register set, a specific channel to be used, and then it tells it what index inside the interrupt mask register basically is the channel that we need. And so then that way this can have more than like one channel like that, right? So we're only gonna have one for now. So this would be something like that. Apple Dockchannel hid or whatever. And then that will be pretty much whatever goes in there should be the same as we were doing for spy, which I actually don't know what it was. Yeah, hit transport. We don't actually need any of yeah, we don't actually need any of that. So really this should be it. And that's going to be our third driver that I'm going to be writing today. So I think this makes sense. There's debate to be had about how exactly this should look, but I think this will do for now. We'll get the ball rolling, and I can shove it at at the device tree guy at Rob, and see if we need to change it later. Yeah, I think we don't need anything else. Oh, yeah, no, we don't. Okay, so let's actually put this in the device tree, put the real numbers in there, and then actually just write the drivers after that. I usually keep these sorted. I don't know if this is all properly sorted. I think it is. Let's put the register names in first, and then and fix it. I need to open up the ADT. Oh yeah, there are power domains. MTP fabric. Now those are the perf registers, though. These are the. Oh, but NTP fabric has no power state. NTP. Oh, GPIO. Okay, but also has no power state. Base also no PS. Perif also no PS. UART no PS. MTP CPU also has no PS. Spy also has no PS. I2C, SRAM. Yeah, I think nothing here has at least assigned power states. So if they exist, we don't care about them. Yeah. So here are the actual dock channels. This is we don't care about the first register set. This is the interrupt one. And then the actual FIFO would be the 3000s and 3.4 for the data. Which means this is more correctly named like that. That should be it for that one. And then, let me just refresh that so you can actually see. MTP transport. Yeah, Apple has a lot of extra stuff here that we don't. And then MTP is here. This should be. I forget which one's which. I think the. Actually, where was the SRAM? I could see that in the logs. Yeah. So we have 24 ECA 1000 and 24 EC9 C00. So the SRAM is 9C00. And the size of that is at least 5,000, but I think we can safely say 8 for that. And 40C9, 4040. I forget how these ASCs worked. I think it was register 0 for the. I totally forgot which one's which. Hardware ASC. This was done ASC base regs. Okay, at 0. Yeah, I think it's just 0 and 8 for the top one. So I don't know what the other one is. But it should be here for the control registers. And the mailbox should be at that plus 8,000. And this will give us the interrupts, which are in this order, and only the mailbox has interrupts. So we actually have them in the right order in Linux. Which means this is the correct address for that. 23. Oh, did I forget to change that? 2484. And then the Dart is this one. We're not going to use the APF. That's going to go in Mini. So I have to write some Mini code first to make all of this work. That is 2, not 3. It should be just 4,000. And we do have an interrupt for that. Cool. And then, so the other final missing piece here. Just one sec. The other final missing piece here is that this HID transport stuff kind of needs to depend like on the other thing being up, and I don't know how this should be specified yet. So something like that, I guess. It's kind of yeah, unclear how this should be referenced. And then I think if we do that, I'm not sure if we need like a helper cells. Probably do. But yeah, this is you know all about bike sharing the bindings here. But I think for the purposes of today and you know, first viable version, this is how we're going to do it. So now that these addresses are correct for E8 or E4, okay, so this, we keep things sorted. 24EB, that goes, interesting, that goes before the dock channel, and then the mailbox goes after, in principle, goes after MTP. I think we usually be putting the mailboxes first, but I might want to fix that later anyway. Just keep everything sorted by address. Yeah, that makes sense. I think I have the addresses right. Yeah, looks about right. Okay, so let's just take that. Oh wow, I got like 50 viewers already. Wow. Okay. Yeah, let's just take that and stick it right into here. Which in order would be after the 2s, 2, 4A. Yeah, right after that. So between pin control and ANS, that kind of makes sense. Fix the tabs here, which of course I messed up. Something like that. Oh, that one makes sense because it's actually because NVMe does have DNS afterwards. So if we sort by the main address, that's how it sorts like that. Yeah, I think that makes sense. Make sure I close things with semicolons because I always forget that. And that has the interrupts, has everything, I think. Oh, Dockchannel interrupts. Yeah, I'm missing that. The Dockchannel. And there's also UART, by the way, which I might want to implement as a test too, but we don't have a way of listening on the other side. So there's the Dockchannel. I don't think we need the GPIOs. Seems to work without them. So we're going to ignore that for now. And we're just going to say, you don't need interrupt names. There's a single one, 850, level high. Kill that. Yeah. I think that's pretty much it. What is Dockchannel UART connected to? It's connected to the debug USB device, which we don't know too much about. I did some fuzzing of that way early on. Found, like a high-level interface for reading registers just by sending it garbage over USB. But it's very... It's on the wiki, but it's very... like, it's a big question mark right now. Apple calls it KISS. What was it? Kanji in system or something like that. Kanji in system, I think. It's basically a built-in USB debugger. And you can trigger it from any machine that can send VDMs, and it's not even like the UART that needs the special pins. It can go on the regular USB pins. So in principle, you could connect to it from more devices than just M1s without any extra hardware, as long as you can control USB PD. So you still need, non-standard stuff. Yeah, it's the same. It's the stuff that Satan was writing about. But we don't have the software, the Kext, that handles that. So we don't have any reference for the protocol. We don't have the firmware for that. I assume there's possibly a little tiny Cortex M3 or M0 with ROM firmware handling that inside the M1 and the M2. It's definitely a ROM, because this works even where like nothing else works. It even works sometimes with like the chip off, for some definition of off. But yeah, we don't know much more than that. So one interesting thing is that if you write to the UART Dockchannel, something else is reading the other end. And it's not instant, so it's not hardware. Like Mini will race and win. So that sounds like it's some kind of CPU like polling at semi-slow intervals, so as to not waste power. Like Python wins the race, but it's not for long, because if you wait like a few extra milliseconds, it disappears. So there's something reading the other end of that Dockchannel, but we don't know what it is. Well, we know what it is. We don't know how it works. I might try fuzzing that again in the future just to see if I can figure it out, which would be pretty cool. It'd be like I figured out a USB device with no vendor driver just by sending it garbage and figuring out how it reacts. Like if we can actually pull off enough to get Dockchannel to work, using that reverse engineering approach, that'd be pretty fun. I should definitely stream that when I get to that. But yeah, no, not today. So yeah, today this is the device we were going with. That should be everything we need. And now we need to write the drivers for that. So the first thing is actually that Mini needs to get taught how to initialize the APFs. That can probably just go in dart.c. Well, this is getting pretty large. Maybe it should be in a separate file. I guess we can make it the APF and then just have the init stuff first. Oh, they actually read stuff? Wait, where'd that come from? How that hex dump we were calling poll. Oh yeah, we were done reading everything. So that's so this is the packet that it sends at init time. Yeah, sorry. Yeah, it's fine. Okay, let me just reboot that. Let's make some new files there. Open dart.h, do a bit of copy and paste there. And for now, we're just going to have DAPF init from ADT int, or actually even just node. Yeah. Do I need path trace for this? Yeah, because it's then I might not want to use that API. Yeah, I'll make it be quiet on errors so that we can just ignore the return value from the caller and call it a day. Don't even need types of H for that. Oh yeah, and this is the prototype. No such thing here, but the APF. In the future, we might have more DAPF stuff, but for now, we can just use that. And then do a bit of copy paste here. And that's going to be the same code as we have in the example here. Also, this should be in the proxy so that we don't have to deal with that in... so we don't have to deal with it in Python anymore. So I might as well put that in here. Oh, why is this... Why do those have... Yeah, shouldn't have that. DAPF init from ADT. Stick that in the proxy. All right, that goes in there. Need to include that. The APF. There's going to be more than one of these because we had the AOP, which was a bit different. I don't know why it has a different... Maybe it's because the Dart is a different type. Because that one had filter data instance 0. I don't know if that's different than in the... It's based on the Dart type. AOP... Dart... DAPF instance 0. And this one has... Yeah, it's the same. Okay, so probably it's just different in the different arts. ADT.txt. Yeah, that one says filter data instance 0. And if I look at a recent M1, there's AOP. That one has filter data instance 0. Yeah. So I probably should just look for the... I can just look for both. Nah, but I think... let's look at Max Studio. That's still filter data instance 0, yeah. So I'm guessing that just goes with the Dart compatible. So let's just do that. Let's just follow the Dart compatibles. So we can basically copy and paste all of that. DAPF. Dart path, software trace, ADT. But we're not going to return an error in that case because I want to just unconditionally run this. Yeah, we just hard code that to 1 for now. And then if it's T8020, then we do return into 20, just pass it the node, base node. That's the same, and then that's the same as that one. Path base. Turn -1. And then we're going to have 2 different structures for that. And I'm just going to look. I haven't run a trace on these, but I'm just going to take a quick look at the firmware data and see if I can guess how those writes worked. Yeah, so it's just like that. So we have, yeah, this 301 looks the same as the ones that I saw here. And then UNC2 is the, yeah, that was, it's pretty much the same then. It's just the structure is slightly different. So in that case, what we actually have here is, something like that. And the one that I figured out, let's get this in here just as a reference. And this would be UNC5. And this is the same as the, where am I? MTP. And then we had UNC1, which might as well do it 2 bits, I guess. Yeah, there's a lot of padding there. And then we just keep that the same, basically. Oh, did I just overwrite that? Sorry. Yeah. So we have 2 there. T8020 and T8110 config. See, this is where if C were like a reasonably polymorphic language, it'd be a lot nicer, but unfortunately, it's not. So yeah, I guess we just write 2 almost identical functions. So T8020, let's just write that one, get everything done. Base node. We need to get the tunables. How does that work? There is some tunable stuff here already I can steal. PCIe. Tunables apply local. Oh, we do have a tunables. Let's see. Yeah, we just need a get prop there. And so we can just do struct. dpf t8020 config equals adt get prop adt node. And that one is called filter data instance 0 length size t length if not config or not length or percent size of is that a thing? Oh wait, I don't need type of, just say size of star config. Something like that, and then just do just do a 4 there, maybe. There's a count. And this one is called unc5. Actually, are these the same offsets as for this one? No, they're not, actually. Yeah, so the DAPF has also changed. The entry size has also changed. Because this one is 40. AOP had... Oh, no, they both have 40, but yeah, things have moved around. Can we write 64 this stuff? Probably. From is at 8. Yeah, that looks right. It is, yeah, write 64 does work. Not all the bits are implemented because this doesn't have an address space that goes that high, but yes. So we can just use write 64, makes life a bit easier. So for T8020, hopefully this works on T8020 too. I'm not even going to test it, but we'll find out. Probably can test it later if he wants. Config, unc5, base plus 8. Not 7, 8. This is from start 10. Oh wait, zip. Oh, okay, it just yeah, we're supposed to get the Yeah, we could check the bounds on that, but it doesn't really matter. And then base 0, 0 would be 3, 1, which is the same thing I had for this one. I was calling that UNC 6 and 7, but I'm calling them 2 and 3 here. And that's a guess. That might be wrong, but for these cases, it works. And this is right 32. Okay, so that's the T8020 in it, and then the T8110 in it is very similar, but this is called DAPF instance 0. It's D8110, and then here the algorithm is to and from are in the same place. 0 does get written with that right after that, and then UNC5 goes in. Oh, we have UNC1 and 2 here. Oh, we have both of those. Okay. Hold on. It was UNC1 and 2, so yeah, let's call that. It would be 5 and 7. And yeah, 5 more of those. Yeah, so then we have write 32 at 20, config I, 5, and then at 4 we have. Oh, that should be actually UNC5. This is the same as that one. So let's do it like this then. Call that UNC5, UNC6. Sorry, UNC5. Actually, let's actually name them after that. Let's call it R0 high, R0 low. This one, the UNC6, is the one that we're writing to R20. Then we have UNC1. Then we have the R4. Yeah, something like that. And then I can do the same thing here. So this would be 2, and this would be R4. Wait, T2020, I got something wrong there. This is base plus 0, sorry. I'm editing the wrong one again. Yeah, I'm editing the wrong one again. Okay, hold on. Take that. Put it back. Yeah, I'm doing this backwards again. Yeah, yeah, sorry. No, this one's fine. That one is fine. Filter data instance 0. Start R4. Yeah, that's it. I don't think the order matters either, so we can just keep that the same way. For MTP, just keep it at R4 start end. Well, we did put 0 at the end, but R0 high, R0 low. Put that there. And then we have more, though. 20 is R20. And that's it. Why is this written? Yeah, it's just garbage. Okay, that should do it. What do I have wrong here? A lot of things are wrong, apparently. Finite from ADT. Oh, I need to... the APF. Yay! Let's delete the junk. I have my targets set up here. Yeah. It's supposed to be a what? U32. Okay. Path. Yeah, we don't have path here. Oh, yeah, we don't have the yeah, might as well pass it. Make that static. And that's -1 there. That's config I. Const. Yeah. Turn 0. There's a build now. Yes. Cool. Might as well keep these like that. Okay, that builds. And so now I should be able to literally just comment all this out. Also, this can go away because we put that in the setup script. And we can just do p dot DAPF init from ADT. I don't know if we need that TCR on the Dart. That might need checking in the Dart driver to... No, we always enable that. We use the TTBRs to control that, so that should be fine. So I can just comment that out. I just need to add that to the proxy here. Add ABF init from ADT. That should work. Chain load. Make chain load Python MTP. Dart. Oh, I do need the Dart. Error getting DAPF instance 0. Interesting. Yeah, well, that would definitely not boot without that. AOP. Oh, wait. Let me make a better. Invalid length. Probably means I need a pact on this. Do I have a pact? Yes. Though that should align anyway, but yeah. Ah, yes. So I think it worked now. Might as well put that in here. Put the common message in there. Okay, that works. Yeah, that works. Cool. Okay, so that takes care of that. Hopefully the IOP one also works in the other machines. So now I also need to just do that in the Linux boot stuff. Where did we do those other random things? Yeah, USB init, PCIe init. Let's just do DAPF init. And have an actual init in there. And that'll do like everything relevant for this machine. I guess I might as well print the errors here. DAPF. And then just do a check note here. Do I want to do that? Yeah, it doesn't matter. You can just do everything like that. So in that case, let's actually make the proxy thing have both. DAPF init, all DAPF init from ADT. Actually, I guess I just call it DAPF init all and DAPF init because it always needs the ADT because that's what a tunable is. So I might as well just call it DAPF init all and DAPF init. In which case that goes in here. Call it DAPF init. The build. Yeah, and so did I keep up with any Connect DIY things past initial work and Open Connect pre-Connect? Yeah, not really. No, I didn't even keep up with the Connect 2 stuff. It was very much kind of like moved on to other things after the initial driver and sort of engineering work. I still run the wiki website though. It's surprisingly still working. But yeah. How many of those do we have anyway? AOP, PMP also needs that, and MTP on DCP apparently. Does it need that? I would think iBoot already applied that because DCP is already up. I don't know DCPX though. Oh, ISP looks suspicious. That one might need it. Oh, and A&E apparently. But yeah, I guess let's just do them. At least everything that doesn't have clock gates. And power gates. So we don't want to do like A&E, and we'll see what we do about A&E because Linux might have to initialize that if we have the power gates involved. But though I'm kind of tempted to basically make the pattern be that Linux just the Linux Dart driver reads out the DAPF and then lets the Dart power gate and just keeps that. So in that case, Mini would actually turn on like A&E and all that hardware, or at least the Darts, initialize the DAPFs, and then let Linux turn it back off if it doesn't need it, and then it would save as part of that process if it needs to. But yeah, for now, let's just do the ones we really care about, which MTP, PMP, AOP are probably the big three that are immediately useful. Do we have array size here? No, we don't. Yes, we do. No, we do. Okay. I should have had array size in here. But just make it null terminated, whatever. And then I can do ADT Yeah, it should return negatives. Didn't we have an 18 node exists? No. Okay, right, -1, and then I'm just gonna say count equals 1. Actually, just do it like that. Okay, should take care of that. There's a build, not quite. DAPF init all. Okay, that should take care of initializing before Linux runs. And then in here, just to prove that this works, I can just say init all. Make sure the proxy side is done in Python too. Get rid of the path, init all. Okay. That worked, and it actually initialized all 3. That's cool. All right. Cool. Bunch of less stuff we need to care about here. I don't need SMC. Don't need any of that. And then AOP. Hopefully, I can literally just do that. All right. So that's the mini side. That is the mini side. Now we can write Linux drivers. First up, I guess the ASC driver, which is really going to be the helper thing. So let's go to Linux. That's going to go in sock because it only makes sense there. And we called that MTP. We called that a helper ASC4. Let's just call it articulate helper. Okay, config, make file. Actually, No, we're doing it like that. Yeah. Yeah, might as well just do it like that, I guess. So then in the kconfig, yeah, something like that. Apple RTKit helper. Now we have to Asahi update Asahi soon. Finally, sound. Nope, sound is not production ready yet because we still don't have the volume limits worked out. So that's gonna come later. I mean, sound already works if you do it manually, but under your own risk. So okay, RTKit helper, and now I can probably just kind of steal some SMC code for this. Drivers, MTD devices. Was SMC there, or where was that? Not MTD, sorry. MFD. No? Where did I put that? Where did I put SMC? Oh, Mac SMC, sorry, yeah. No? I put that. Oh, under platform, was it? Platform Apple Mac SMC, yeah. And the RT-Kit one is specifically the one that we need. So take that. And there are no endpoints. There's nothing here. None of this stuff. We do need the RT-Kit ops. We don't need message early. I think we don't need rest. Does the RT-Kit even does it require that? No, it doesn't require that. So we only need the shemem ones. Isn't this broken? We always have is mapped false, so yeah, this default is actually broken, I think. Not that we're gonna use that anyway, but yeah. So no receive. Do we need crashed? No, we don't. And we already print that, so we only really need the shmem ones. Let's just replace SMC with helper everywhere. Place all. And there's no core. We have that. Shmem destroy. Yeah, so we need the SRAM. Do we need SRAM base for anything? Oh, that's the. Oh, but we don't actually need that because yes, yes, we do. We do need SRAM base. Yes, that's fine. In this case, it's not wake. It's we're actually we need to boot this, which is going to be a little bit yeah. I think we don't actually have common code for that. We probably should, to be honest. Because these are the same pretty much everywhere. And that's right, and we don't even have resets for this CPU, so I guess in this case, this one better be able to get shut down. That's a good question. Does this work if I shut it down and does that work? Can I boot it up again? No, not via message. But yeah, how does that even work? Because we need to clear the CPU run bit. Or does it just stop itself if I clear the CPU run bit? That's a good question, actually. Stop should do it, though. Oh, yeah, actually stop, not shut down. Okay, claims to have done that. Can I bring it up again? No, it does via message. Why does it do via message? It does call shutdown. Set CPU control to 0, yeah. Oh, is it because it's running as 1? Yeah. Okay, so that doesn't quite work because the CPU is still running. Oh, okay, but it does work. It did work if I just ignore the is running thing once. Oh. Hold on. So Jen now says gist. But this shouldn't go in mailbox though. That doesn't make any sense in mailbox. We don't want that in mailbox. Because this is controlled by the RT-kit side. So it's not something that we want to like unconditionally run. And also this is the wrong algorithm because we now have just learned that we have to leave that bit on. So yeah, that's not where that belongs. Unfortunately. Yeah, it works every time I change the file. Yeah, so it works if I send the message and boot it, which means it's actually going into standby. But I don't think that's... Oh, interesting. So it doesn't work if I MBIQ... Oh, crash log. Really? That one's interesting. Oh, I know why that happens. That means Apple's driver is buggy. Remember I sent this message here, message DVA, because Apple was sending that. We don't have to, and Apple's driver is buggy because it sends that. Why is Mini not connected? What now? Yeah, and it should not overflow this time around. Yeah, so regular shutdown. There's not what's going on here. Regular shutdown works fine. Like it's going into standby mode. What about, weren't there states less than 10? I think I'm probably just using the wrong state in that case. Like a 2 or something like that. if I set the state to 2, 1 apparently, will it come back? Why is mini like not working sometimes? Okay, now it says 1. Okay, message did not work. What if on stop I do actually do shutdown? We don't do the start there. Let's just do boot. Actually, because I didn't do shutdown yet, let's do shutdown boot. No. Why is... Nope, that doesn't work. So 1 kills it, but then... Maybe there is no way to get this one back after a full shutdown. Which kind of sucks for things like KXEC. But we should just make the... We should just do the sort of safe startup process that works for both cases. Where we set the run bit to 1 and send the message. Which is not what I do in Mini. But basically, that should be a safe process. And then in that case, if I look at MTP and just do a regular stop, it should actually work. Why is every second boot not give me the interface? Yeah, so now it works every time. I don't know. If there's a better way of doing this. But for now, I guess we'll do with that. We'll go with that. So, and I think this is the same thing I was doing in like the DCP stuff in here in Mini. Where am I? Do ASC init. Oh, and we clear it. Oh, we clear it at the beginning. Just assuming, yeah, it should be running, and then we do CPU start. So we actually aren't doing that here right now. But I guess DCP never gets shut down anyway. Was it NVMe that I... Maybe none of them were actually using this protocol right now. I think that was just something I tested then. Not NVMe. ANS. No, it is NVMe. ASC init, yes. Oh, is it only ASC init? You're doing RT-get sleeps and then just calling pmanager reset. We're never calling the CPU. We're never saying the CPU start bit on this one. That's a bit weird. Yeah, sleep is 1. Off is 0. We haven't tried 0. Should try 0, I guess. I don't know if that's going to work, but... No, that totally kills it. Yeah, it's a good question. Yeah, that one sets it to sleep, which is 1. So that one does kill full power, but then... Yeah, and this is wrong, though. So then we should actually just do the CPU stop there. That would be more correct. And in that case, before the pmanager reset, has the interior engineering helped to understand the M1 better in any respect so far? Well, we did the missing Dart driver that is needed for M1 Pro and Max. And also this Dockchannel stuff also applies to some debug things in the M1 which we haven't implemented yet, but don't have a use for. Hold on. CPU stop. Where's the ASC? Oh, these are just globals. Yeah. And RT-kit init does take an ASC. Oh, we do call ASC CPU start an RT-kit boot. Yeah. So this is so this does follow that unconditional stuff. So really, the right thing to do would be to do it here. Okay, that one doesn't do anything, so... Yeah, that makes sense. Yeah, so it would be nice to know what iBoot does for the MTP. But in this case, for the helper, the SRAM region should be optional. So that's fine. And then we need the CPU control stuff, which is in, where am I? In Linux. Yeah. Yeah, you can just do wake, which kind of supersedes boot. Maybe we don't need the owner for that. Okay, don't need any of that stuff. Don't need any of that stuff. Don't need shemem. What was that? I don't remember what that is. We have ASC base. Don't need that. Probably don't need delay. I don't think I have delays anywhere. Device IO port. RT kit. There's no helper H here. So if buffer IOVA. No, wait. We need to give it an IOVA. Wait, no. 1 second. If not buffer IOVA, yes. If not buffer IOVA, then we just do the DMA thing. And just do DMA autocoherent. Helper dev. bfar size, bfr IOBA, GFP kernel. I don't. It sends them up if it's not mapped, so we don't need to set that. Um, I don't think that logic really makes sense, but whatever. Yeah, so if it doesn't have an IOVA, it does that. Otherwise, it actually checks to make sure that it's in the SRAM. So we'll do if yeah, that should work. And then for free buffer, we actually don't need that because it's else if buffer. Oh, which we don't never set, so we don't have to care. I forget how that's supposed to work, but I think we don't actually need the destroy. It's just that it but we only need to but it only checks if there's a buffer. So actually we don't need to destroy either. Because we never set that in here. So we don't actually need that. Yeah, something like that. Okay, so now we do the init, we turn it on. Otherwise we try quiesce. None of that. And we're not doing any of this init stuff. There's no endpoint start. We just wake it up and that's it. And then for remove, if it's running quiesce, I guess. That one was quiesce, which is 10, which is the one that works so far. And then I guess clear that bit. And that's just called helper. And finally, from the from the device tree, what this should be binding to is MTP RTK helper ASC4. That's pretty much the entire driver then. To be honest, this SRAM stuff should kind of be moved to the RTKit code because SMC is using the same logic basically. But for now this is okay. Can always refactor things a bit later. Let's see if that builds. This should be RTKit helper 2. Yes, that's 2. Yes, cool. Let's see if it builds. Probably won't. Syntax error. Yeah, that would happen, wouldn't it? 732. Hmm. What? 733? Oh, 0x. Yeah, helps if I make my hex numbers actually hex. Missing one. Uh, 765. Oh, comma here. Okay. Now, it's not ANS anymore. It's ASC CPU control. Okay. DMA allo coherent, where is that defined? Ticket internal.h. Linux IO, Linux DMA mapping. Where's the get cookie thing? You don't need that. There's no core. Remove is just platform device. Yeah, there's none of that. We need to just set this as the dev info or whatever that was. There's a container off there. Where is this set? Yeah, platform set driver data. That's what we need. Then we just get driver data here. And I think everything I allocate is devm except the get resource by name. Oh, but that's fine because that I think doesn't need to be freed. Have ANV somewhere. helper. And alive is not necessary because, yeah, we just do that. There's no cleanup apparently. Yeah, because there's none of that. Okay, let's see if that works. So now, if I am right, this should give me some syslogs from where's my there? That's not Linux. Articate failed to wake up coprocessor. Okay, let's do trace MTP. And see what happens. It works? No, it didn't. No, it doesn't. But now I got... Wait. It did start the syslogs. Okay, something went wrong, but... Yeah, it does start initializing, and then it explodes. Somewhere. What's the last thing that happened? Oh, the art mapping, and then it gets... It gets an SRAM address, and it doesn't like it for some reason. 24 ECA 1000. I did get that right here, didn't I? MTP. Wait, 24 ECA1. Yeah. NCA1. Yeah, that's in there. But didn't syslog work though? Yeah, 24 ECA 1000. Wait. Starting in point 1, 24 ECA 1000. Yeah. Why is that? Bit confused as to what's going on here. Also, I have too much spam here. Let me trace a bit less because that's a bit ridiculous. If I look at Where am I? Mini proxy client H3 trace MTP. Oh, it's already doing that. Bit better now. Still pretty spammy though. This shouldn't be using verbose 3 for that. Just one is enough. But okay, let's see what happened here. So set CPU control to 1. Gets the hello, set IOP power. Yeah, that's the redundant one, which is okay. Hello ACK, EP map ACK. Starts endpoint 1, starts endpoint 2, syslog. Starts endpoint 4. So this one, yeah, 1, 2, 4. And then that's it, and it just stops there. I get the feeling that this is just kind of broken for DMA buffers in general for some reason, or something went wrong with that. Although DCP works in principle, so not sure. Oh, it needs shmem destroy. That's why. If it has an IOVA, it needs shmem destroy. That's why. So we do need that no up. That's why it's not. That's why it's rejecting that. Where is SMC? Okay, let's try that again. Failed to wake up coprocessor. What happened this time around? Same thing. Oh no, it does give it an address. And then why is it getting another request on 1? Which is never act. Oh yeah, we're not supposed to act it. Okay, that is weird. Why is it getting that twice? Were we getting that twice in Python? No. No, we only get it once here. So what gives? Are we sending something twice? Wait, is the Dart not working? Oh, I know what this is. This is a crash that is not getting reported properly or something. Yeah, that's a crash. That's just an actual crash. Because it's supposed to do that twice. Why is our ticket not reporting a crash though? Crash log buffer size. Oh, are we not setting size here properly? Ah, we need to set size. No, we are setting buffer size. Oh yeah, it does set TCR 0 first. But was it 0 or was it 1? I think I got the offset wrong. MTP. Yeah, it's stream 1. So that's one problem, but the other problem is that the crash isn't getting reported properly. Why? Crash log RX. Because I do want that. And so the timing can be weird. No, but it's not doing any messages though. It should be reporting the crash. Unless the buffer is larger than I expected. I didn't actually check that. That sounds like a bug. Oh, and now it works. Well, thank you. Hold on. Where's the wake up stuff? Minus 62. Gotta wake. That just does boot, and boot calls wait for completion. If crashed is enval. And then it returns boot result. Enval. Let me just turn on debug on this. I get the feeling there's a race or something. Oh, it waits 1 second. What is minus 62 actually? Eat time. Okay, so it's just a timeout. Oh yeah, it times out 1 second later. But then why was the crash log not doing its thing? But actually, we should just complete the completions after the crash, to be honest. So why was I not getting the why wasn't I getting the crashes earlier? Yeah, it was just timing out that time. Maybe I just had the wrong log. Yeah, okay, now it's actually crashing. Yeah, okay, so now the crash is expected. Don't print that. Let me make sure it's actually doing that without that printf, and yeah, then we just fix this stream thing. Should be that one. Yeah, okay, it does crash, so that's good. Let's reboot. Yeah, there we go. That works fine. Yeah, and I don't even need to do the device link stuff this time, probably, because I think I can just treat the drivers as independent. I do want a reference to handle like suspend and resume properly. We have to figure out how that works, but you might be able to get away with having it completely standalone this time around. In fact, Apple might do it that way, to be honest. So yeah, that works. It starts the processor. So now the next driver. That's 1 out of 3 that I'm writing today. Next is Dockchannel. So drivers. This has to go in sock, I guess. Dockchannel.c. Git commit. Yeah, would be. I should do that on Mini too, but not that. Oh, wait. How did proxy end up with that? Uh, yeah, there's a lot of things I need to add here. Everything from last time too, but I haven't actually added new files, but and yeah, let's also do that. Um, Shutdown there should only be called in the case where we actually in that case, basically. Uh, I don't think that one matters, that change. I think we can undo that one. And just make sure that actually works. Yeah, that's fine. Then didn't I remove that from the hypervisor? Or is that not using whatever? Mm-hmm. Oh yeah. Mini shell add I mean, and then do the CPU stop stuff. Okay. Yeah, should be fine. And then I probably want to add some of that experiment stuff, MTP. Dockchannel, yeah. Experiments MTP. Okay, that's the mini side, and then the Linux side. Let's take config make file. That makes sense. And then the well, I can commit that later when it all works. Okay. Next driver, dock channels. Drivers, sock apple dockchannel.c. Okay, config make file. Yeah, let's just call it like that. Okay, config make file. Apple dock channel. Dock channel. Okay, that's that. And I'll steal the basic scaffolding from this one. No RTKit on that one. No DMA mappings for this one. This binds to Apple Dockchannel. Okay, so that has a dev, IRQ control data. No SRAM for this one. Set driver data. Say IRQ. That comes from IRQ base, control base, and database. IRQ base. IRQ. And I guess for now we can just support a single dock channel. Something really the binding needs to be generic. I don't want to change that. So config base. Why does it do that doesn't make any sense. That and then return EIO, what? We're doing the same thing in helper? Yeah, it doesn't make any sense. Was this like an is error or null or something? Yeah. There's fit here or 0. Something like that. That makes more sense. But this should also have is error on here. Oh no, that's error. Yeah, that's fine. I shouldn't need or no in this case because I think it never returns null. Because it's not the get by name thing. So that should be fine like that then, I think. Okay. Let's do an old config. Yes. Okay, now the registers, based on what we have in the Python. Get rid of the prefixes. It's too annoying. Okay, that should work for that. And now we need an IRQ. I steal that from somewhere. Yeah, Devin request IRQ. Apple Dockchannel IRQ. Okay, Dockchannel probe. I should fix my language server so it stops doing that, but I don't know how long it's going to take to init on here. This might not be a good idea. Ah, there's a script for that. Cool. Is that it? And now it's thinking. Aha. Interesting. So it like does all of them. Okay. That's gonna take a while, isn't it? Okay, it is taking a while. I guess it's parsing output. And then ClangD runs. Oh, is it going to take that long for each one of them? Oh, that's not good. Yeah, this might not be a good idea. This might not be such a good idea. I mean, it is kind of did something, but yeah, it's not doing great, is it? Is there a thing? Yeah, but ClangD is not um is not what's taking time here. It's Kate, I guess, parsing ClangD output. So that's not great. Um okay, kill. Oh, and I started another one. Okay, let's get rid of that. So it does the same thing it did before. There's a limit results 500. Yeah, okay, now it does that. Yeah, I don't know if Incremental documents. I'm not sure if that's useful. Yeah, I don't know. I don't know. If this is going to be some way of making that not slow. So let's just skip that for now. Anyway, Dockchannel. Yeah, whatever. We'll deal with that. Let's just try get old config in there. See what it says from compiling. Yeah. RQ return T. See RQ in here. And I guess in this case, well, we are going to eventually need some remove stuff probably. Non-void. Yeah. IRQ. Oh, is it handled? Not handled. What was the not handled version of that? I forget. IRQ none. This doesn't actually matter, but in this case, so this should be relaxed, otherwise Maz hates me. And I'm going to do my right 32 thing because I hate having those backwards. No, I guess there's not that many of them. I guess I don't need that. Right L relaxed. Yeah, it's value address. So in this case, read L relaxed. You get the data. I need to do the channel thing. That means reading some device tree stuff. We're gonna steal that from SMC maybe. No, they didn't have anything interesting. Where's one that we? The power states have that. Drivers, power, not supply. Where's the Gen PD? No. What was that called? Oh, it's in SOC. Platform, Apple, SOC. No, it wasn't here. I really forget where the drivers are. Power state. Where is that? It is in driver SOC. Apple P Manager Power State. It is there. Yes. Yeah. Redo 32. Apple. and that was called. We need FIFO size. Yep, that gets that. Okay, so and the IRQs, which one was which? The, okay, so now we need the init. In the init, let's clear the IRQ mask. And then clear all the flags. So now I need to like do a DT probe of the sub channel. I guess I might as well write the the functions first that we're going to use. So this will be int apple dockchannel send. So for sending, what we do is well, count. Basically the same thing as the Python, right? It's going to be this logic. While count is greater than 4, this is not a mailbox driver. This is definitely not going to be a mailbox driver. It's not the same thing. But even if it were, no. So while count is greater than 4, let's just say while count. So while we have anything, we can make the loop a bit simpler then. First, we see how much space is in the FIFO. dx3. I need some like unaligned read primitives here. We used that in this like I squared C or something. And this would be LE32, I guess. Just do like that. P. Yeah, greater than or equal to 4. Thanks. Yeah. So we write as much as we can. If count is still there, if we still have some count left, then we actually, I'm going to do one thing. I'm going to pull that again. Yeah, I'm going to keep pulling the free register because if the other side is actually reading fast enough, we don't want to even try using interrupts. Might as well just let it just keep writing until we actually run out of space. Anchor and P in the right case. Yes, thanks. Actually, you know what? Might as well copy. Let's say actually, and I can make this a bit simpler. I can just say, well, count 0 there. Write everything. Block there and say if space is 0, then we wait for the completion or whatever. And we're gonna use the same thing as the helper thing. Use a completion for that. txcomp, rxcomp. Oh, you're right. This is memcopy2io, isn't it? What was the in place thing? It's not 2io. It's the in place thing. Um. Oh right, yeah, no, it isn't memcopy2io because I need to. It's always the same register, right? But isn't that a different thing? Because when copy to IO actually increments, I need something that doesn't increment the register. But I think there was a thing for that though. Yeah, it's not those. Yeah, I need like the one that is like a FIFO write thing, but there was a function for that. Didn't we use that in like SPI? Oh no, we didn't. No, we didn't use that. I think there was some reason we didn't use that. Yeah. No, this will be TX8, and actually in TX8 we need to shift, don't we? Mm -mm. Oh, no, we don't. Not for TX. It was just for RX that we need to shift. Okay. That's fine like that. Then if space equals 0, did SPY do something similar? Yeah, we're just calling wait there. Yeah, that just waits for it's basically that, yeah. We're not polling, so it's just yeah, we just need completion. And yeah, and we just enable the completion stuff. For RX, I guess there doesn't necessarily have to be a timeout. Oh, write SL, that was a thing. Oh, IO read 32 rep. Those are the ones that yes. But do these have to be aligned though? I guess it must be an assembly language. Yeah. That's the ARM32 version, though. There's the ARM64 version. Oh, it doesn't have one. Yeah, but that's the thing is it's not. It assumes the buffer is aligned. Is the problem with these, and that I need the unaligned thing. That's why I couldn't use these. Although in theory, this CPU is fine with unaligned accesses, but I don't know if Linux is really intended like to allow that. Probably not. Yeah. So let's just do it like that. And if says equals 0, then we read completion txcomp. Wait for completion timeout. Dockchannel txcomp. Was the TX8 path tested on the Python side? I don't think it was tested because I was always sending a multiple, but I think it's not shifted. Because I think I saw macOS do the writes like that. I think I checked that the other day. Yeah, so we need to set the IRQ masks here. Do I need write L here? Does this order with the IRQ? Because this needs to happen after the completion is reinitialized, but yeah, I think I probably actually want write L here. Yeah, so then we set the FIFO depth, and we want to IRQ. Probably when we have exactly as much space for everything, or actually just say threshold equals this is it like this threshold if count is greater than Dockchannel FIFO size, then we set that to the FIFO size. This is say -4. Just a guess. Actually, no, because you don't know the speed of this, so. Yeah, I guess might as well always use a FIFO size -4. Let it write all the time, then. Yeah, let's just do it like that. Config base. Yeah, it needs shift one way, but not the other. It does make sense because when reading, it returns the FIFO depth, well, below byte of it, because it can be more than that now. But when writing, there's nothing to set there. Did I kill the renit complete? No, yeah, we need the renit completion. And the mask should really be cleared by the interrupt handler, to be honest. Yeah, something like that. Actually, let's just say left, and then I can just return count. Apple Dockchannel send. That should be a decent implementation of that. We need init completion, though. Okay, and now we receive It's basically the same thing, but it would be rx count. It would be avail. Actually, we can use avail everywhere. And in this case, we can have the full FIFO size. Yeah, no, might as well do half again, yeah. It's basically the same logic. Yeah, it should be pretty much that logic, except this is going to be redo, reduxed. Is there a put on a line U32? Yeah. And also, RX32 is not shifted because there's no space for that. Yeah, that should work. Yeah, that should work. By 8? Yeah, it's 8 bits. The low 8 bits have like the FIFO depth at that point. So you throw those away. That was designed when the FIFO was not going to be more than 256 bytes long. Okay, so that's good for send and receive, and then we need something for getting like a callback or something when we're waiting for data. And I don't know if this should be a blocking thing, because that means that you need like a thread. But I'm more tempted to just make it a how does because normally you would get an interrupt when data is available, right? So it makes sense to use to get something called an interrupt context And yeah, I need some kind of like wait avail thing. Awaiting or something. And then I can say on if awaiting, data available. Give it a cookie. And I need to move something to a header file, but for now, let's actually read the available data count here, because that's useful. Yeah, and so then we can have Apple Dockchannel await count, and in that case, we just write it. And the threshold is going to be min Dockchannel 5. In this case, we can go up to the FIFO size and count. We can use that to cancel the await. So if we set it to 0, we can just say on Dockchannel set that to false. Set the mask to 0. As well return threshold on that, I guess. Set it to true, set the threshold, then the interrupt. Yeah, make sure that that's ordered with the other right. Return the threshold. Await. And then we set awaiting to false here. Otherwise, complete the completion. Say we handled it. But then we need to actually clear the mask before, because otherwise that function could re-enable the interrupt and want to trigger it again. It's fine clearing the flags afterwards though, because they will not clear if the mask is set again. So that's fine. Yeah, that makes sense. Yeah, I guess maybe just give it the callback here too. Yep, and now the interrupt enable. I guess we don't need to enable it. Request RQs should do it then. Yeah. Okay. Which means I better enable the completions first, in case that fires for some reason. Yeah. Yeah, something like that. And now the client driver, I guess. So we need a Dockchannel file. This is in sock, so include Linux sock apple dockchannel.h. Just get everything there first. Get a bit of stuff from the top here. We need an if? No, we don't need the well, we can, yeah, we can just do that, but get some prototypes in here. Dockchannel, where am I? Wait, where did it? No, here. Sock Apple Dockchannel. Mm-hmm. So how are we going to identify dock channels? And because we need, I can get that from the parent device, but then I also need the specific channel number. Which I could get. I need to let this driver do whatever it wants with driver data. Let's look at how the hate spy transport thing works. Mm. Oh. Mm. Where was that? Spy hit Apple is what that was called. Okay. Yeah, but it's not. Do we need threaded interrupts for this? We might. I'm not sure actually though. Let's look at the actual core driver. Because I need to probably steal stuff from it here anyways, so. What folders do we have here anyway? Surface hid, yeah. It's just random. Apple hid or yeah. Where is that? Source. I need to source that. Spy hid until hid. USB hid. Dock channel hid. Hey config. Now, this might be similar enough to the actual protocol that actually let's look at that first. Let's see if it's close, because if it's close, then this should be renamed from spy hid to um, Apple hid, I guess, and then we can have both in the same directory. So let me look at the stuff we were getting from the experiment, which I can just run. Uh, experiments, MTP. Let's get a shell on that. Nope. Crash dump. That's nice. Int object is not subscriptable. IO translate. How does IO translate return? Oh, yeah, that's kind of wrong. It's supposed to be like that. Okay, it works now. So let's look at the spy hit protocol and see how much we can share, because this is a pretty big driver, so. There's a spy hid message header. Yeah, the CRC is reminding me of that. Spy hit is still very much weight, but not finished driver. Yeah, that's fine, but I still want to see if it's the same protocol or not. Because if it is, we should be using the same code. Yeah, so the keyboard data looks like that. 8, 12, 14, 0, and then that increments, and then there's some kind of checksum, but that's not a CRC, though. The CRCs don't behave like that, I think. Yeah, I know the size is fixed for Spy, which kind of makes sense because of the way Spy works. Obviously, this is different because this has flow control. Spy doesn't. But what I want to know is whether some of the headers are the same, or at least some other stuff is the same or not. Because at the very least, packet flags, packet dev. Yeah, it's a CRC, but this doesn't look like a CRC, I think, so I'm not sure. But there's also it's also like 32 bits somehow, so I'm not sure about that. Or maybe there's like a CRC for the header and one for the payload. But this looks more like a checksum, just by the way it's behaving. Oh, maybe it's header checksum and data checksum. Because this is 28. Yeah, okay. It's header checksum and data checksum. And then we have report keyboard 21. Keyboard is number 2 here, though. So that almost looks like it's kind of different. Descriptors. Then we have 1001 and 1002. This looks like a length OA, quite possibly. Let's look at the big thing at the beginning. So it starts. Okay, so 0812 is apparently constant. The other thing that looks like a length. 1400. Which would be this much. And then 402, yeah, okay. So we have 0812 16 size. Then that's just a counter. It does go. No, it doesn't. It does. No, it's just that many. And then the next one is the device ID, I think. Okay, so we have that. And then the zeros, we don't know what those are. Then it would be payload. Yeah, I think that's it. Yeah, so it's size 50 starting here. So yeah, that lines up. And then there's another size 50. Yep, ends here. I can see 0812, and that's the last one. STM reset and AFE reset sound like the GPIOs, actually. So this is for device 0. This is for device... Is there also 0? Yeah. These are all device 0. So these are like control messages. So what about the HID reports, though? Oh, we do have a bunch of stuff here, yeah. — 5000, that does, and then, yeah, so that one starts there, the 048. That's the message beginning. That one is the message beginning there. Just do it like that. That actually starts there. And then we have the keyboard. E400. These are all for 0, right? Yeah. TPXL. That's the next one, and that's it. And then for the key presses, what we have is that. So that OA is another length, it looks like. Yep, ends there. So there's padding at this layer, probably to a multiple of 4 or so. So then the inner format. Okay, so that means I can just get rid of those like that. 48. Yep, get rid of that. Why is it adding 4 bytes at the end, though? I'm not sure why there's extra 4 bytes there. 92. DA. Yep. .3F. 48. Oh, that's interesting. Okay, is there more? Oh, is it multiple packets inside one packet? No, it's just that I didn't break this up properly. But it always seems to be zeros at the end there, so I'm not sure about that. Maybe there's always a zero there. Or maybe it does support multiple packets, and that is the terminator. And then we have this one, which is 3F00. Which means it ends there. Oh, but wait, it always has zeros here. Maybe the length field is just that. Wait, no. Or maybe it's just another header field actually. But in that case, there's somehow the last bytes are always zero, which is a bit weird. So maybe not. But yeah, they always seem to have zeros there, which is. What about the keyboard ones? Yeah, it has zeros there too. So maybe the header is 8 bytes. Oh yeah, it has to be because otherwise the keys will overflow. Yeah, no, that obviously that. Oh, A starting here. No, it's starting here. Obviously. Function is that one, right? Yeah. Yes. Okay, so it's not zeros. It's just laying another unc, then the data, then we pad to U32. Okay, that makes more sense. And then the actual hid reports start with 0, 1. I think I've seen that before. Where's spy hid Apple Core? Yeah, report keyboard starts with 1. So that should be the report number or something like that. Um, aren't these standard HID? I've seen this stuff before. Isn't this like 10 thing? Well, we don't have that here, but I've there's something um like doesn't HID Bluetooth do something like that? Where's the tables? Give me the tables. Is it in the header definitions? Uh, oh, okay, that's the type. It's 5. Yeah. Yeah. Look, 5251. Set input report. Set output report. It's Bluetooth hid. Because guess what? Bluetooth hid is the same thing. It's hid over a byte pipe. Um. So what are the init messages that I sent doing it? I bet it's the same thing. Interestingly, there's no there's B4, but maybe that set report is not needed for init. It's only for changing the type, and it starts up in yeah. Yeah. And so then the other messages data 10, which is A1, in that case this one's different. Nine is set idle. Is there a 0? 5 is set report. 1 is hit control. 0 is handshake. So what are we sending when we send those things? MTP. Let's do a bit of decoding this. Okay, so sending data apparently starts with 1108. That's starting to sound like 8 is the header length. So what we have here is header length. Okay, so there's those are flags. 80, whatever that is. Then we have the length. Yep. Then some unknowns. Then that's the actual payload, which is 2, and that's padding. So it's just B401 is all it's doing. And then it says B402 to the device number 2. This is, yeah, device number 1, is it? No, it's backwards. What? No, that's the counter. This is device 0. Okay, yeah, so these are sending it to device 0. What's B4? Is that a thing? Yeah, so basically what you're saying is the spy one matches the the Bluetooth HID, but the Dockchannel one does not. Because 2010 2. Net report is 4. Set protocol is 7 something, which we don't set. Anyway, then what we actually get during init is if 001. Could B401 be the Unicode value? What do you mean? For what? B401? I'm not sure what you're talking about. The init message? No. That's like command B4 and O1 is the device or whatever. Like because in this case it's initializing the trackpad and the other thing. In fact, I can just like do it like this. Oh wait, why is the payload checksum the same here? Is it an XOR or is it really a checksum? No, but it should still do that. How did that work? Did I miss the... I'm gonna have to make a proper tracer for this eventually anyway, but for now, this is doing... Let's look for the rights. Yeah, there. So it is FF1ECC2. And then FFF1 is... Yeah, it is FFF1. Why? Okay, that's weird. This FFF1 means I have an E somewhere here. Wait, that's the header checksum. No, that's the data checksum. What? FFE1 Is it the everything checksum? Yeah, E1A. Does the header checksum match? Almost. It's off by 12. Just 08? No. Wait, that one, the first one is. Wait, now the second one is not. Oh, it's just a 32-bit checksum? It's just a 32-bit checksum, isn't it? Oh, it's just a 32-bit checksum for everything. Duh. That's why. Yeah, because this one's also decreasing. Duh, yes. CBA9, and this is, yeah, no, BF, yes, okay, I'm just stupid. I missed that one was decreasing. It's a 32-bit checksum of the whole thing. How many devices do we have? Let's just do 560, what happens? It crashes now, probably because I don't invalidate things or whatever, or because I reloaded. Don't know why that happens. Okay, trackpad didn't do anything. Should have up to 5. Keyboard interface configuration completed. SD management ready. Actuator interface. Whoa. Checksum error. Well, thank you for telling me. E9B. Oh, no, it is because this is a 5. Interestingly, it didn't like me sending those like that. Excel ready. Yeah. Actuator ready. SD management ready. Keyboard ready. Grape interface configuration completed. Mm. So what happens after that in the trace? Oh, it's not even before every time. It does. Okay, so the first thing it sends is actually I can just grab that on the log. So it initializes 1, 2, 5, 4, 3, then does something else. So after that we have C1 108 OC. I think the index doesn't actually matter. But it's the same thing. Oh, okay. It's different device, so the sequence number is reset to 1. So now it's sending to device 2. And the length is 40 here. That is still 2. And then we have zeros. And then just 01. And the checksum, which is B5EC F F1. Yeah, F1 FF. That did something. And then it does 202, sends a 1. Sends the same thing twice. Yeah, not sure why it sends the same thing twice. But let's actually put these things in there somewhere. And then it sends 18 bytes. 6. $80. It's 10. 0. Yep. And after that, it's 9502. 0001. And then 21, and then more zeros. And then 8E32 100. And then the checksum, which is 4EB9 B5FE. Did not like that. And that was not a checksum error. That was just like an outright crash. Well, that's great. 21. Oh, that has an address in it. Oh, that's evil. Okay, so it actually does need the IOMMU on this device, and it uses memory buffers. Oh, come on, why Apple? Yeah, sure. Ha. Well, that's oh, that's interesting. Okay, maybe I'm not finishing this today. This is a bit more ridiculous than I expected. Of course, it's a bit more ridiculous than I expected. It's Apple. Okay, we need to write a proper tracer for this. It's not. I just stopped looking at bytes like that. Trace MTP. Dart tracer. We need some kind of thing. Some Dockchannel tracer. Let's just put everything in. How do I want to do that? Some easy tracer like I squared C. No, that's already done as I squared C tracer. Yeah, sure. Just look at that. Trace. Yeah, we can just steal the dart from that. MTP. Okay. Trace MTP. Don't need to trace devices anymore. Dart tracer start. Hardware. Dockchannel. Import everything. Then in Dockchannel, you just use the registers. Reg maps. None for that one. Dockchannel IRQ regs. Oh, hey, thank you. Thanks for the super chat. IRQ regs and config regs data regs was the order. IRQ config data default mode. Yeah, there's the trace sync for this one. Super start, nothing there. So let's do R. How does it read? Yeah, it always reads in bytes, it looks like. Actually, I can just support all of them anyway. Shift 8. Actually, I can just do that every time. From mini trace, import AT dev tracer. Let's get all the utils. Mini HV trace mode. Dockchannel, import everything from that. I guess I might as well put this in Dockchannel tracer. And then I can just move that to there. And then we don't need that. NTP channel tracer, sure. Channel tracer. Don't need that. And so now TXRX class. Let's do an MTP. Stream. call it hit tracer, I guess. I might as well just do like that, I guess. So I do want to reinstantiate these classes. So we get a buffer. That should be enough, to be honest. Extreme to extreme. Okay, so we do that. Okay, now decode the header for that. And the size for these included the. Did it include the header or not? '08 C00. No. Okay. Take that. Okay. So we have And then we just hex dump that. There, where is... Let's see if that works. Guest. All right, it's run. Oh, I see. That's not gonna work, is it? Not with the crash MTP. Why is it doing that recently? Start. Trace MTP. Oh, that. And I need a Dart tracer on that. Okay. That didn't actually work. Ah, no, not that. Why? Why no tracer? Oh, super start. Wait, no. Yeah, it should be doing super start, but yeah. Yeah, now it works. No struct. Okay, let's do that again. Probably doesn't need to be verbose now. Okay, what's going on here? Unable to newer USB device. Okay, that's interesting. It's like every second time it doesn't work. Oh, is it just like get reset? That's interesting. Why? Maybe it was just a bad cable or something. Okay, that still didn't work. Dockchannel. That's not how it works. I thought that was how it worked. Oh, because it already is getting register. Right. RX8. No, it doesn't reload that. Yeah, right. Hold on. MTP. Okay, now it works. And I am getting packets. That's good. So we can reduce the log level here. Yep, better. And not print that. What's up with the length 0 packets, though? Those are weird. Maybe those are ACKs or something like that? That would kind of make sense. Oh, C hex dump. Yeah, it really is just totally empty packet. Okay. Actually, let's do that pad equals 0. Wait, why is Rx 0 now? That doesn't make any sense. Does it switch to like shared memory or some nonsense? I bet it. I bet that's like an interrupt, and then it's using shared memory buffers. This is ridiculous. Okay. So, you get what's going on here, right? They have a mailbox protocol designed to be used for shared memory. They ignored it. They started using this Dockchannel thing, which is similar to SPI. And then the first thing they do is switch to shared memory. What? Yeah, all the received channels are like using shared memory now. And on transmit, it looks like it's just also using shared memory, and that's some kind of length thing. Because that's the LED toggle, but it's not actually changing when it toggles, so... Oh, but that is the click. And that is actually sending the whole thing, though. So maybe it's like toggle LED? This is the force touch stuff, by the way. You're seeing there. Oh, but like that time... Yeah, so you can see that this is like triggering like different force patterns or something. Okay, so let's see what we have from the beginning. Do I do anything to have a low live latency on the stream? What do you mean low live latency? It's set to low latency on YouTube. I don't know what you mean by low live latency. So anyway, the second header is 000 and then the length. And this seems to be a flag of some sort. That 80. This looks like a proxy for those GPIOs, which is a bit interesting. So I guess that 80 is some kind of packet type flag because yeah, that's an ACK. That's an ACK of packet ID 2, I guess. No, it's just an ACK of whatever device ID. Oh, you're talking about the clock. Yeah, the clock should be NTP synced. 30, 60 seconds of delay? No, it's not. That's not normal. Um, that's only if you're like behind at the playback side, and you should set the video speed to like 1.5 and let it catch up. Okay. So MTP trace MTP, and now we have packet. So dev 00, packet 00, yeah. So I guess we need some kind of device class now, because this is just for the streams. And then we can just call packet. Leave the hex dump in there, and then we can do packet. This is very similar to the SPI ticket protocol I just using on for the AirTag UI. Okay, well at least they're using this for something else. So it sends AT00. That was wasn't that the init? And then, or am I doing something? No, what? No, something's wrong. That length is not right. Where did I get that length from? Oh, it's H size. Sorry. I should just do it like that. Yeah, it's not -12. Yeah, that's why. That's why. Okay, that makes more sense. So I was dropping data. It's just -4. Let's do that again. Oops. Channel tracer. Let's just pass that for now. Okay, now there's a bit more data. Yep. Let's reboot, get that again. Yeah, okay, so this is the whole thing it sends. On TX, you get 0, 0, 80, 0, then... Yeah, so that might be like a message class or something like that. And then you get 40. So 80 sounds like it could be like command and then reply. Because then this replies with the exact same thing that we sent. No, actually. Length 1. That's interesting. I thought that was a length, but apparently it's not? Maybe it's only a length for this type then. AFE transport is what they call it. um, but AFE is analog front end, so I'm not sure why you would need. I thought AFE is analog transfer. Yeah, Z2 AFE transfer initialized. So why would saying the buffer like turn that on? Maybe the keyboard stuff that we get like by default is some kind of like iBoot type protocol, and then we're supposed to set that buffer. Okay, I think that is actually the length, and this is just padding, and of course it's uninitialized because Apple. So yeah, then it is actually a count. Interesting. Here we got something different in those bytes there. Wonder what that is. Oh, and there's calibration blobs and blobs involved. Yay! Okay. So the links are right. So it looks like the acts are basically just the command ID, and that's just the buffer being like that. So we need to get that length and actually pay attention to that. And it looks like the next byte is probably like a command ID of some sort. But then I wonder about that flag byte thing. Okay, so 4,000 is command, 8,000 response. So I guess 80 and 40 if it's Little Indian. And Caesar on a sync event, and then one is like um some kind of notification or something. But in this case, it's not command and response. Because it's transmitting and receiving stuff with 40s, so it looks like it's always using 40 for device 2, 80 for device 0, but sometimes it receives stuff, right? 00 looks like some kind of notification, I guess. Yeah, because it's getting this is the ACK, and 00 is like async notification, I think. The next byte almost looks like the device ID. I wonder if that's always the case for the management commands. It looks like it, yeah. Yeah, okay, then that kind of makes sense. Then 00 and 80 are like the management stuff, and 40 is the like actual device command thing. I should just switch the contract for this, shouldn't I? I should just switch the construct for this because I'm just reinventing construct at this point, and I already have perfectly good tooling for this. Uh, yeah, construct class. Yes, there's gonna be a lot of nesting here. Init misses. Init message. So ungoogleable. Conditional. So init message would be type is that how you do consts in construct? I think so. Value subcon, yeah. No, this is the same machine from the beginning. Also, this isn't an M1, it's an M2. What I'm looking at. F0. I guess that always has to be 0, 1 in this case. I have a padded string thing here. Let's reboot, I can look at the logs. Yeah, padded string, which is in... Was that a normal construct thing? It might be. Hmm. Okay, yeah. So yeah, padded string of length 16. I assume these are the HID reports. Because that's the only thing that makes sense, really. Okay. I don't know what that 24 is. Is that the length 6E? No. B6? It could be. 6E. Yeah, that actually does look kind of right. And then, yes, okay, so that's the HID report length. Or is that just what hit reports start with anyway? Do they start with a length? E6. Wait, no. B6? If that's the length, isn't that from further back? Because it goes to E4 minus B6. To E? That doesn't... Yes, that does add up. Yes, it's D6. Yes. So D6... Okay, yeah, so it doesn't there. And then there's a 2, which also looks like it could be a count there. And then there's a 24. Yeah, and then there's a 2-6. Okay, so it's another layer of packets with lengths. Why is this so complicated? Why is this? How many layers are they making in this? These aren't multi-part though. They're just like broken up for some reason. So assuming the 48 there is really the length, and it started here. Sorry, yeah. This looks like an init thing. That might have like this could be the type and then a length. You sure this? I might just reverse engineering HID descriptors at this point. No, but not for the GPIOs though. Hold on. Open up the hit spec just to make sure I'm not being dumb. Okay, so we're looking for like usage pages. And that's like a 5 or something. Yeah, okay, so that's probably the beginning of the actual descriptor at the 5. So it just has the length before that. And then this has this 206 thing at the end. Okay, so hit report 00. Then we have a length. Yep. And this is also a length for the GPIO thing. So in this case, I need to select. The init message is device ID, device name, and then we have init message type. No, and then we have and then it's a greedy thing. So that means init message block. Init block. That has a type and subtype. Actually, no, this is fine. Hit report, I can just do it like that. Yeah, GPN, I can do it like that. No, but I want to have the length anyway. So I'm going to use case. Switch. Yeah. Okay, so init block type subtype switch. Block type. Block subtype. Just call it subtype and type. It's a separate thing anyway. This dot type. That's just int 16 UL. That's not how you do structs. What am I doing? So it's type, subtype, length. And then there's a sized or something. Fixed sized. And then GPIO init is 2 unknown fields, then looks like 32 bytes of text. And then we have 206, which should be a terminator. Is there like a pass or something? Wasn't there a thing in the ADX stuff that Nino's working on that used that? The is it the micro sequence? Repeat until, yeah, this kind of thing. Repeat until. Should work like that. Just press a init block until that equals to terminator, and then payload fixed sized switch default greedy bytes. So is there a null or something I can use here? Pressed lazy bound, none of, one of, indexing, slicing. I mean, I guess I can just do like byte 0 or something. Or just terminator. But yeah, just byte 0 is fine. Okay, init block. Greedy bytes. So it's repeat until that init block. Yeah, that should work. And hit report is just the report. Actually, I can just say xstump there, but I do want to have the data, so I guess it makes more sense like that. GPIO init would be 2 unknowns, and then a padded string. Init block. Hit report. Something like that. Init message. Okay, so that's F001. And then finally, if I and then I need like the actual Also, I'm typoing this. And so then for those, we have flags. Then the length. Unknown. And select, was it? No. Yes. Okay. So then we have F001 is the init message. F1 F10 something is the config complete. Device ready message or something. F1 device ID and then unknown. Then we have before means. But those are like then it's not like this. Sorry. This is for fixed size, this length, select, and then it's no, it's a switch. For 80, for 0, and 40. So for 80, it's is that always the pattern for the 80s for the this is C1 TX. Yeah, not clear what's going on there, but it does return with a 1, so there is 8004, and then yeah, so the receives already is returned with an ACK. Okay, so I should split that up. So we have flags, length, unc and message. Actually, let's just say command header. Flags length. Oh, then I can't set flags. So then let's say tx command, tx message and rx message. Message header. And now we switch on flags. So 80 is something like device control message. Rx message header associated device control ACK. Okay, so that's the ACK device control message. Are those always fixed size? The 8000s? I've seen 4 and stuff. Okay, so 0 is 80 is that one, device control, then this would be init message. Actually more like notification. And then there would be a selection. You can skip the thing there. Device control ACK. Yep. Device control message. Command device ID RX. Yep. Init message. Device ID message. Yep. That's F0 unknown device ID the init message. Yeah, that's a message. Okay, let's see if this parses. TX message, RX message. Yeah, that should work. Let's get rid of that. um. Okay, let's see if this insanity actually works. Unguessed. Repeat until line 55. It's missing a comma there. Oh, and this actually, what I want is, yeah, type 2, yeah. Missing a close there. Okay. Flags. It's not this flags, it's this header flags. Hey. That's actually pretty good. Init message, the rest of the multi-touch. That didn't quite work though, message type. Oh, no, it's because I, missing that. Okay, and the one that screwed up is no subcontract matched. Yeah, because 0000. 14, and then that's a command of some sort. Okay, let's run that again. Bytes of attribute flag build none. Oh, greedy bytes. No subconstruct matched. I thought I added that. Oh. No, wait, receive 0. Oh, it's another notification. In this case, F001, device ready, F1. Yeah, so this is let's just say greedy bytes. Yeah. Streamless header flags. Wait, weren't I'm hex dumping before parsing, so also MSG is why is MSG getting probably because I reloaded and it's not doing yeah. Um why is it parsing? Oh, because it's an empty one, isn't it? That. Right? About HN. Ooh. Okay, something went really wrong now. Oh, I know what the problem is. I can't do that until after the thing is, yeah. It's very confused now. Let's reboot. I can't consume this in the buffer until after I know the packet has been parsed properly. Why am I missing what is that? It's like Greedy Bytes doesn't get the address for some reason. Oh, because it doesn't have a length, which it wouldn't. And then it doesn't have an offset too, and then it gets confused. I'm confused now. Why is it logging something and then failing? It's an RX message, but there's no hex dump. So what's in log data? F7? Oh wait, for starters, this is kind of wrong. I should be using need here. Oh, I'm dumb. Okay. Yeah, it's just the nulls. Okay, so that does parse. Message none is a bit weird though. TX message. Oh, flags 81. Okay. Something went very wrong there too. No, but that's because I restored and probably something weird happened there. Okay, let's do a reboot. Do another clean start. And I might be calling this a day because I was not expecting all this bullshit. Because of course Apple had to overcomplicate a freaking keyboard. Um, no, it didn't work. It's one of those hypervisor doesn't start moments. Yeah, the flags are just the upper 2 bits, I think, yeah. But then there's something else in the lower bits. Okay. Proper USB communication? This is not USB. This has nothing to do with USB. So I'm not sure what you're asking. I had the USB spec earlier because this is HID and HID is based on USB. It started out in USB, but it's not USB anymore. I should do something about those lengths being off. It's probably some way of doing that. If off the size of for just a size of none, and then do set it there, and if size of is none, break. And then when we print that, I should just do that should fix that. Can I do that? I don't know if that actually works, but I'm gonna try. Looks like it does. Still get nuns though, so maybe it doesn't. That one did work though. But then the 80s also failed, so that did not work. Only zeros work now. Oh, not 30. C0. What am I doing? Okay, at least now this is showing the right thing. Header message, init message, type, yep. Why is there a name here? Wait, what? No, that's not how this works. That's not how any of this works. What? Oh, because name is already, yeah, is a thing. It's a reserved field name. Okay, getting somewhere. Oh. 8101. Device ID. That's a device control message. Flags length unknown. DB. Oh, yeah, you're right. There's no device ID of that one. So I guess they're not always like that. Oh. I think I'm losing state. Oh, I know. I'm not losing state. I'm right. No, this is right. Oh no, it's gonna put the same thing again. Because yeah, okay. Yeah, that's better. Yeah, now it shouldn't break when I stop it and run it again. Okay, now it looks like it's working. I should hex dump those greedy bytes. HSM get D. But there's not even any D here. Is it the top bit? It does return a D. Okay, so let's look at the beginning a bit. So device control message, command B4. Device control message needs device enable message. Yes. Device enable. Sorry, that's what I wanted. Yes. So that sends enable message for device 1. That's interesting. It sends B402. Where'd 1 come from? Wait, isn't this backwards? F1, wait. F102, B402. Okay, so it's the device readies that do that. I'm, oh, B401, it's there. Yeah, okay. So you get, no. Hold on. The keyboard is device 2. Device 1 is multi-touch. Why? I feel like I'm off by 1 on the buffer. I feel like I'm off by 1 on the buffer, and for some reason. Nah, that actually doesn't make sense, but still gonna do that. Why is it doing that now? I think my USB cable is just degrading. Yeah. Device enable message. That did not work. Uh, Same message twice. Nope, something went wrong there. Um, oh, len buff. No, len new buff. No, len buff. Oh, wait. What? Wait, what am I even doing here? Um, I'm tired, okay? This doesn't make any sense. USB cable. I mean, it's like the problem is probably like my breadboard and the pin header is plugged in. Thanks. Okay, it's not broken anymore at least. Okay, yeah, so now there's a transmit in the middle there, which is what I thought. That sends enable for device 1, then we get the ACK for device 1, and then it sends enable for device 2. Device ready, device ID 2, then it says enable 5. 5 is ready, act that. Enable 4. 4 is ready, act that. Enable 3. 3 is ready, act that. I feel like I missed one of the readies. The ready for 1? Did I miss F101? Or maybe they just don't come for those. Because that's the was it com? No, it's the oh no. Oh yeah, it is those. Oh, there's one. This oh, it came after the transport enabled thing. Did it cont? No. That was when something went wrong though, so I'm not sure. But that looks valid though. The F1 looks legit, so I'm not sure. Cumulus the port? Yeah, it should be right after that. Okay, so that 3 makes sense. Since device control command 3, HSM get 3. If I interface 1, which apparently the low bits of that is the interface. Okay, so then the next thing, that one that initializes that, this one, the buffer thing, whatever that is. So this is where it gets interesting. Oh wait, I know why I don't see that device init message, because um I think that just takes a while to initialize, and by then we are in this mode where all the messages are coming in through the shared memory. So command 95. I'm not sure if that's really what it should be, AFE transport. Yeah, and it gets the ACK standard, and then from then on, it's all going to that shared memory. So dev2. Not everything comes into that, but a lot does. So it looks like probably it's used for unsolicited messages. So the except this one here that is still 0, but maybe that was the last one or something. Um, no, wait, maybe. Oh, yeah, there is one. So it's 95, unc1, 2, 3, buffer address, and then another unknown. This might be 64 bits. Let's just say it's 64 bits. That could be a length, but I guess we'll find out. Actually, let's just dump the Dart, and that'll tell us stuff. $2100. Yeah, it is consecutive, and the size is 14,000. Does that match up? I think so, yeah. I think this is the length, the buffer length. Yeah. What was the length? Well, 1.4 will do it. Oh, great! It's got the it's got the yeah, the IOKit dictionaries in here, of course. Oh, right, and the calibrations, yes, but those are the dummy calibrations because they uh So I don't know if this is a read or a write though. That is a lot of junk in here. Um, let's get a mon going. Where's mons? Didn't I have a mon already for some of these things? Yeah, I just need to initialize one. Trace MTP mon reg monitor. Then in start, buff size, and then finally if I'm just gonna be lazy now. Message. Device control message. Device. I need to do that. Actually, this should actually always work. Almost, except when that's not a hex dump. Message that buff header. I actually want to get one of those streams and do. We did have that, or actually no, we didn't. No, we don't. Not on this one. I'll just use translate. It is consecutive for this one, so one. Oh, and then I need mon pull like all the time. Let's pull every time we get a packet before printing anything. Translate is it is state buff. That is correct. Buff header is the message thing, but reg monitor. Huh? Dart tracer. It's just Dart, not Dart tracer. Unpack requires a buffer. Oh, is it because it's not a that's not doing anything. That's there. Oh, I'm not calling initmon again after, yeah. On start, I need that. Self.initmon. Aha, that's more like it. Yeah. Did I have a hex option for regmon? ASCII, yeah. That's more like it. Well, that's lovely. That's not actually monning anything. Maybe that's not the buffer. Maybe there's another buffer. But tracer. Is it one of these? Oh, there's a big buffer there, actually. Oh, so it looks like this address that is being provided is actually like a config blob or something, I'm guessing. And then this other one is the actual, yeah, because this is the one page that RTKit uses. This is something else. Ooh, that's a lot more. It looks a lot more like reports or something. It's also huge. Okay, so where is that? Before that. It's before the AFE init stuff because that is logically. So I'm looking for C00 in the transmit message. There. Or not. 91. Yeah, 91 is kind of suspicious. C. One second, I'll be right back. Yeah. Let's see. Maybe there are even separate buffers being defined. It should be for this though. Just sort of in order. I'm just gonna grab the logs. Uh, it's OC. It's yeah, C000. Yeah. That's not it. That's just one of the units. I don't like the alignment of this one, but yeah, probably. And it gets a null right after that. Is that the first time that happens? Yeah, I think so. Okay, so it's not. Yeah, so that one is like a big calibration blob or something. Oh, that's gonna suck. Um, and then there's that. And Q1 has two more arguments, then a buffer address and the length. Yep. So that's not the one I want. Init AFE message, I would just dump it at that point. So here I'm just gonna read it. That's 91. Int buff message. No, touch X request is the previous one. Because this gets sent afterwards. So touch X is device control C1, I guess. Yeah. Yeah. Don't know if that's right, but C1. And there's a notification that we don't know about. A001, A703 something. Yeah. Okay, let's try that again. You know, I'm once I see the packets in the monitor logs, I'm calling it a day. This is a lot more ridiculous. Why is everything always more ridiculous than you expect? The good thing is we shouldn't have to use that DMA buffer stuff because obviously the packets are happy to come in through the regular endpoints. So, but what worries me a bit is that configuration blob, because that doesn't look eh. Oh, the buff is too small. Mon. What am I doing? Yeah, that's more like it. Yeah, there you go. It's extremely slow now, and um, why is it such a giant buffer though? That's kind of ridiculous. Um, but yeah, like, whoa, what? Oh, is that just like another like random data that changes every time? Okay, where's the HID report? Why is there so much garbage in here? I mean, are you kidding? Okay, so it's a ring buffer, obviously. And it has counters at the top with read and write pointers. Okay, so they added another byte transport and another ring buffer. um, okay, there's a hit packet. Now I can see the hit packet there. Oh, yeah, okay, so it's the same thing. It's the same 0812 packets as always, in the same checksums. It's they're just going in a ring buffer now, of course. And as you can see here, 17E8, 17E8, probably plus 17E8 plus I'm guessing the first two words. Yeah. No, the swap is because this is printing as 32-bit words. It's just because it's meant for registers. Um So 17E8 is the offset, and it's counting after the headers. Then 18E8 is the right pointer. $18.08, yeah. Why do they allocate a ginormous ring buffer, though? That is ridiculous. Okay, so looking at the beginning where it all starts. $6C. Yeah, there's a bunch of packets that come in at that point. Yep. Yeah, that's the flags. No, it's not the flags. That's the. Is it the flags? I'm confused. No, that's the that's this one. The HLAN M type size counter divide D pad. The good thing is, thanks to me having reasonably engineered this, I can pretty much just create 2 new streams, push bytes to them, and it will magically do the right thing. So no more mons here. And then in pull ring, the first one is the remote right pointer. If the pointer is as a read pointer, There's only an RX mem stream, no TX. Buff size. I'm assuming this is going to wrap around how I expected because I don't see how it would work otherwise. Buff size minus minus 8 minus RPTR. And then after we put if that succeeded, then we need to update the read pointer. Otherwise, we'll screw up the sync. So at this point, we update the state. And its size is right pointer minus read pointer. Yes, this is for the trackpad, but also, I mean, the keyboard works because it doesn't need any initialization. The trackpad apparently needs some in it. But also, I can't see the keyboard messages. The keyboard never showed me the messages from macOS. That did not work. Tuple and int. Why tuple? Because I did not do this. Aha, and now it just dumped the entire buffer. Cool. Hey, there's the keys. Maybe. Yeah, the keys are there. On there? Oh, there they are, yes. There's other stuff, though. There's some kind of, like, log message involved, too. Because, of course, there is. Because there's your keyboard messages, but there's def1 trackpad messages, even though I'm not touching the trackpad. And if I do touch it, then of course everything comes in there. So there's your oh. Oh, look, and the multi-touch is actually variable length. That's cute. That's pretty cute. Yeah. Anyway, the keyboard works. I don't know what those messages for device 1 are, though. But it's the same. It's the same data, though. It's the same data for device 1. When I'm touching. Maybe it's like a power management thing, because you get an 88 there. So maybe as long as there's any key press, you get an 88 there. Yeah, so you get the key report first, then an 88, then the release, then a 0, and then another 1 there. So yeah, I wonder what those are. But it just seems to be the report from the touchpad, so... Oh, and there's something else there. Oh, that's the lead. Yeah, so that's the LED state. 102 means the LED is set. 100 means it's turned off. And there should be a transmit message. Yeah. Yeah, it's just an ACK. So this is the set LEDs. Okay, so let me reboot just to get that AFE blob. Now the backlight I'm pretty sure was done with I'm talking about the caps lock LED. The backlight I think is just a separate what now? The backlight is it's a separate PWM device that shouldn't have anything to do with the trackpad, I think. Yes, these should be hit reports. I'm just curious as to why I get reports on the trackpad when I touch a keyboard. Okay, so there's that horrible blob of whatever that is. Oh, I know what this is. This is the firmware. I bet, among other things. Because of course Apple loves not uh actually flashing things these days. Look, this is isn't this ARM? Yeah, that's ARM code. Yeah, that's the firmware. Well, that explains that. And so, OS. And the question is, where is this firmware? We have this stuff in the zip file, but does this actually get copied somewhere, or do we have to read it from RAM, or how does that work? But yeah, it's in J493 multi-touch, which I already extracted stuff here when I was experimenting with this. And in fact, I think I know what this is going to be, because this is going to be a freaking plist, isn't it? One of the 5 million binary plist serialization formats or something. Because this is this XML file. Address. Yep. Well, it's good that I already wrote a partial parser for this nonsense the other day while looking for the firmwares, because apparently we're going to have to ship this. Well, the good news is it's just a giant blob, which means we can prepare this in Python, give Linux just the blob. That's it. Now I want to know where macOS stores this, though. It has to store it somewhere. So which of the million serialization formats is this? Is this one of the ones from DCP, or is this something new? It doesn't look like... It doesn't have a BP list header, at least. Mini proxy client, mini firmware, DCP. Where did I put these things? Wasn't this an IPC.py, or where was this? Is IPC object? Was this only in the tracer or something? No, OS dictionary. Where is OS dictionary? In common, firmware common. OS object looks for a tag. That's not it, because that one has actual also emask h address. That doesn't ring a bell. I mean, those are obviously packed. There's OS serialize. And that one's the one with 32-bit text, which also isn't this. So it's yet another one. What is this? It's going to be one of the BPLS formats, isn't it? No, it's not a file system format. It's a plist because I have the XML with this contents. But it's just another. This is like the fourth plist serialization format I have to deal with. Yeah, it's a B plist. That's a string. Unicode string number of chars. Then no, not Unicode. 6 8. Okay, that one's a lie. It's not Unicode. It's ASCII. But otherwise, it doesn't fit. 8E would be UID. No. Okay, maybe it's not that, but it's close. Array fits though. A4. Array of 4. Because what we're expecting there is uh also there's two of them here. So it's this subsection of the plist. Okay, so yeah, it's a different format, but it's pretty similar, right? So this is a dict of 4 elements. So the tags are different, but it's the same idea. And then we have strings, and then 1A is int. That's the same actually. Except 2 to the power of 10. That's not right. Yeah, so it's very similar to BPList, but it's not BPList because of course it isn't. Yes, we need to send the entire blob as is, but we need to get this blob from somewhere, and this blob is not in the same format. This blob is an XML file in the restore zip file. So we need to convert from XML to this. Uh, uh, hid firmware. What do I call this? Hid firmware to blob. The good thing is I started writing this. um, because I also had to like munch the XML, then put it into plist_lib. Yes. Okay, so what we have here is a dict. We do need to get that firmware number, C1FD01, the one that we need for this one, and that's why this is listed in the ADT, of course. It's this one, hid merge personality. Now the good news is, I bet all of this is useful for the touch bar, because there's two firmwares here. One is for the touch bar, one's for the trackpad. And I remember the X2 protocol story as being related to the touch bar HID. So I bet there's a thing there. So C1FD01. And now we need a serializer. So how would you deal with long strings? Let me look at that. This is the last thing I'm doing today. I'm going to recreate this blob, which I'm going to save to a file first. And once I get the same exact file, yeah, if you reset, there's the that's the Oh, and actually, this is a function. Yeah, so those are the GPIOs, but I wonder if those are actually like intended to be called, because it's strictly a function. So I don't know if it's supposed to be treated as a GPIO or strictly as a function. But anyway, that may not matter. We'll see. But yeah, I knew that those were here. I remember that. And these are, by the way, SMC addresses. So if I enable the SMC tracer, we'll see if it's actually calling those functions or not. So stop that. I think it should be dumped by now. Yep. So p read modify write. You need one that's more than that's a 70? 65? Oh, okay, so the long words are all P, probably. Or not. L description 6C. Oh no, yeah, it would be. And then the text for this one is 781F. So yeah, there's something there for the longer strings. So that should be like 1.7 or something like that. 1.8. Is this one of those variable length integer things? Could be. But 70 is apparently means 16. And then I have the ASCII directly. Okay. Oh, it's 70 is just 60 plus that. Oh, and also there's no. Oh yeah, there's a 0. It just includes the 0. So for 16, we just add that. Um, if its instance dict, then O yield, that would be A0 plus L. Elif its instance O list. Then for arrays, I think that's 80. Probably then just everything consecutive. If it's a string, at least that in that case it's 60 plus L. You need to 0 pad it. And then we yield O. That's the one we don't know. What else? If it's an int, it says size 64. I'm not sure if that's really 64. Because it doesn't store the whole 64 bits here. Oh, and it's big endian too. That is interesting. Yield from serialize means like chain a yield. It's like for something in serialize yield something. I'm just gonna guess that this is. Let's do that for now. Abstract. Yeah. Then we're gonna have bytes for bytes. payload. Oh, interesting. There's something interesting going on with the sizes there. Let's just say we don't know yet. And then the object. Otherwise, we don't know. Just give me something verbose to see what I'm doing. Okay. Len str. Yeah. Items list. Oh yeah, lists don't have items. It's just a list. Bytes a string. Oh right. Okay. Looks similar. Proxy client AFE. Well, got the beginning right. Okay, so that read modify write. This is less than or equal. I know that. And then we have a value, which is not a 1A in this case because it's a shorter. What's the value? Two. So that's actually apparently small integers are just stored as is. I don't know how big they would go, but probably up to 16 or so. Int. Okay. If value 19, that's probably 16-bit value. 17 D3. Yep, 19 is a 16-bit value. That gets pretty far. And then the payload, yeah, I'm 4 bytes off, which would be some kind of length encoding. (18F0). Yeah, there's 4 bytes of what are those 4 bytes? It's kind of high entropy. I don't like that. D3 is kind of fishy. How long is this whole thing? There's more payloads there. What about these? So these are... Let's look at D3, D3. I wonder what D3 is then. Is it just an integer encoded with like the integer type or something? And then the data? It could be. The 9F is some kind of... No. But it looks like it always starts with D3, D3. At least let's align it like that. Okay, so this time it's not D3, D3. This time it's just 559. And I don't have two... Yeah, so there's going to be like variable length integers involved here. Um, I'm just going to put the length in there just so that I can see what to expect. 18F0. No, D8F... Oh, wait. Yeah, there's one more. Okay, I can see the FCD8. So it's actually D3, D359 for which is the same. It's similar to this 19 thing. Okay. Uh, okay, that gets that one, right? Then this one is 59. There's no D3, D3. And then in this case, the length is 21C4. Oh, in this case, it's just 59. So where does the D3, D3 come from then? Is that a different thing? That's a bit annoying. Okay, so that gets me all the way to here. Then description is that long string thing, which apparently is 781F. That looks like it's just length 1F. No, but close. Actually, yes, 1F. Okay, so 78. Okay. Pretty close. So now I get to... Now there's 1D3, 5909. I wonder if D3 is like some kind of like there's some kind of threshold involved or something. Just make a random heuristic like this. Will it work? Too many for that one. Not enough for that one. That's too many. Not enough for that one. Okay, so we have... Well, 9BC gets 1. If CD8 gets 2... 188 gets 2? What? That doesn't make sense. Oh, is that the padding count or something like that? No, there's no padding. Oh, is it? Oh, no, but is it just aligning? It's just aligning, isn't it? It's just aligning to 32 bits. It's just padding. It's just aligning. Okay. Which is going to be annoying AF. Because I don't have an offset counter. Come on. All right. So I'm going to then... You know, the ridiculous thing is that it's aligning to 32 bits and then proceeding to unalign, isn't it? Or is it actually aligning the... No, it is actually aligning the thing, yeah. So then it's like align modulo... Okay. I'll just use a special token thing and then fix it here. Um, actually, let's do 4-3. Um, getting there. Why is that one not aligned? 59 to around C4? Yeah, it shouldn't be. Why am I... Increment off on padding? Yes, thank you. Just pad. Okay, getting somewhere. Binary type 78. S request. Calibration 7813. So 78 looks like this goes a bit higher then. Always powered. F5 instead of 1. Always powered is probably a bool. Where is that? Yeah. Okay, that takes care of that. And then report ID 181900. Okay, so group name. (19,007E). What am I using 19 for? That's the yeah, that's the smaller int. So if this has an FF, it would be 18, of course. There we go. iChannels. That's an array of probably more things. 90. Okay, so that does go at least as high as that. Offset, I have an 18, but this is smaller. It's 18, 11. 11 is, yeah, okay, so the integers, at least that much probably go through. Getting there. Interface number. That's interesting. Okay, yes, there's only one thing different. Why is that different? Interface number. It's supposed to be an integer, size 32, value 0. Why is there a 1 on the other one? Uh, it should be ID ref 11. Is it because 0 is like 1? That's weird, though. So if 0 is 1, then what's 1? But that would address... What? Yeah, maybe the interface number is dynamically overlaid by some running code. I think that actually makes more sense, yeah. Um, yeah, that doesn't make any sense. That must be getting replaced by code, yes. Which is lovely, because it means we can't treat this as a fucking blob. But I am not putting this serializer in Linux for this. I am sticking a header on top of this with the offset to the interface number value, and the kernel just writes that one byte. Yeah, that only makes sense like that. Anyway, that's the only difference. Everything else is fine. This serializer works, whatever this crazy thing with a lot of unexplored edge cases is. Okay, I'm dead tired, and this is ridiculous. I'm going to sleep. Why, Apple? Why? Yeah. See you all next time. See, this is what I get. I jinxed it by saying, "Oh, I can get this finished in 6 hours. It's just HID over Dockchannel. How hard could it be?" All right. Good night. Thanks for coming. M2 will have to wait a little bit more. Though it's actually getting pretty close now. It just means I have to deal with this scaffolding too, which is annoying. All right. Good night. See you next time.